Hello students, welcome to the lecture series of circuits and networks. Today we will see what is a filter. Filter is basically a frequency selective network which will select the particular range of frequency while attenuate the different range of frequency. After this one, we will study the graph of low pass filter, high pass filter, band pass filter and band stop filters. Okay, filter is a frequency selective networks. Firstly, I will show you the graph of different filters. This is gain versus frequency. Okay, so firstly we will see the graph of LPF, that is a low pass filters. Okay, so here I will range this F, that is the cutoff frequency of low pass filters. Okay, so low pass filter basically passes for the lower frequency and attenuate at higher frequency. Okay, so as frequencies increases, the low pass filter will goes on decreasing, while for the lower frequency the gain must be maximum. Okay, so after this is a maximum. I will assume this one as 1. Okay, so after this 0.707 of this highest value, we will get what we'll see, the maximum power, and this is called as cutoff frequency. Okay, so cutoff frequency will be differentiate the frequency response in two sides. One side is with higher gain and low, one side which has a lower gain, or here attenuation. Okay, so for higher gain we will call this one as a pass band of frequency, pass band PB. So for pass band gain must be maximum, that is infinite. Okay, and for lowest the gain we will call this one as a stop band. Okay, so for pass band gain is maximum, and for stop band the gain is what, it will be minimum. Okay, so it will start from 0 to fc to infinity. Okay, so here we will write down pass band is from 0 to fc is a cutoff frequency. Below the cutoff frequency we have the pass band for low pass filter. Above the cutoff frequency we have the stop band for the filters. Okay, similarly stop band is started from fc, that is a cutoff frequency to up to infinite frequencies are there. Okay, similarly low pass filter is what, for low pass filter the gain must be maximum only at lower frequency. This cutoff frequency is of how much, 10 kilohertz, 1 kilohertz, 5 kilohertz, and above this one the gain must be what, that should be 0. Okay, so there is no use for the what we'll say low pass filter after this. Okay, now we'll go for the next. This is frequency. Okay, now we'll go for the high pass filters. Okay, so for this this is the response. Frequency. Okay, so again we will take this one as a 1 and 3 dB, that is 0.707. it will come like this one. So here I will write down fc, that is cutoff frequency. So this is a graph of what, high pass filter, HPF. Okay, look to this one, we'll observe that the gain must be maximum where at higher frequency, and below this one the gain must be what, it will be nearer to 0 or it will be nearer to smallest value. Okay, so this cutoff frequency we differentiate two bands, and already we must know pass band the gain must be maximum which will pass the frequency. So this is pass band and this will be stop band. Okay, pass band and stop band. So here stop band is from 0 to Fc, reverse of this pass band is from Fc to infinity. Okay, so high pass filter is what, the gain must be maximum at higher frequency and gain must be 0 at a lower frequency ideally. Okay, now this is a band pass filters. Okay, now we will require the filter which will pass the frequency in between low pass filter and high pass filter. Just remember, a filter which will pass the frequency means the gain must be maximum in between low pass filter and high pass filters. Okay, so what I will take the projection of this. So I will mention FC1 and FC2. Okay, FC1, FC2. Okay, so for band pass filter, just remember the gain must be maximum in between the two cutoff frequency FC1 and FC2. Okay, so here the graph is like this one. So it will pass the frequency in between the low pass and high pass. Okay, so just tell me this is which band. So gain must be minimum here. This is a stop band. Now this band is what, it is a pass band. Then after this again it is a stop band. Okay, so here our band pass filter is a combination of low pass filter and high pass filter is there. Okay, so we'll write down the equation. It will start from 0, stop band, here is there, here is there. It is from where, 0 to FC1 and FC2 to infinity. Okay, similarly pass band is from where to where, FC1 to FC2. Okay, FC1 to FC2. Now I will go for the band stop filters. I will go for which filter, band stop filters. So I want the filter which will attenuate the signal in between low pass and high pass. Okay, I want the signal, or I want the filter which will attenuate the signal. Attenuate means gain must be 0 in between FC1 and FC2. That is called as band stop filters. So it will start from here, the gain is maximum, then it will decreases and again it will increases. It is like this one. Okay, it will be exactly inverse of a band pass filters. This graph is exactly inverse of band stop filter. So here we will write down FC1, FC2. Now this band is what, it is a pass band where the gain is maximum. This is a stop band, this is again pass band. Okay, so again I will write down pass band PB equal to 0 to FC1 and FC2 to infinity. Then stop band is from FC1 to FC2, exactly inverse of this. Okay, so today we will see what is a low pass filter, high pass filter, band pass filter and band stop filter. The low pass filter is what, the gain is maximum at lower frequency, so that's why it is called as low pass filter. And above the cutoff frequency the gain must be what, that should be 0. The cutoff frequency is what, that should differentiate the two bands, that is pass band and stop band. Similarly, high pass filter, for this filter, high pass filter, the gain must be maximum at higher frequency. So for that one we will call this one as pass band, and here we will call the stop band. Okay. Then after this we will go for the band pass filters, which will pass the frequency in between the low pass filter and high pass filters. So here we have cutoff frequency 1, and here we have the cutoff frequency 2. So we'll take FC1 and FC2. The gain is maximum, so that is called as pass band, and here we have the two stop bands are there. Okay. Similarly, I want the filter which will attenuate the signal in between low pass and high pass, means stop the signal in between the frequency range of low pass filter and high pass filters. So for that one I have to use the band stop filter. So here we have stop band, pass band, stop band, and pass band is there. Okay. So this is a practical curve. Ideal curve is looking like this one. This is a gain versus frequency. For low pass filter it is like this one. Okay, this is pass band and this is stop band, low pass filter. Okay, just check it, look like this one. Similarly, frequency versus gain, high pass filter is like this one. So this is a pass band, this is a stop band. Okay, similarly we have band pass filters like this one. It is a pass band, stop band is there, and after that we have the band stop filter. It will be look like this one. So here it is pass band and stop band. This is band stop filter, band pass filter, high pass filter, and low pass filters. Okay. So in this today's lecture we will see the frequency response of low pass filter, high pass filter, band pass filter, band stop filter. Then definition of filters. Filter is basically a frequency selective network which will pass the particular range of frequencies are there. Then we will see what is a low pass filter, high pass filter, band pass filter, band stop filter, its ideal frequency response and practical frequency response. Then how the cutoff frequency will separate out the two bands, that is pass band and stop bands are there. Then we will also write down the range of pass band, stop band for all the filters. Okay. Now the next lecture we will study what is a low pass filter, how to design a low pass filter, what is the formula for low pass filters. Okay. Thank you and happy learning.